This lesson is on segment addition postulate. Some of what we're going to look at today is kind of one of those like, duh kind of things, but we're giving mathematical reasoning to what we're looking at. So the first thing is measuring segments. When we are measuring segments, the distance between 2 points, A and B, can be written as the length of AB. So the distance between it is the length of it. And with that, we can also refer to it just as AB. Notice the notation here, there's no lines written above it, it's just AB, tells us the distance. So if we come over here to the right, we look at these two, and our distance is 1, 2, 3, 4. Or we could have done the math to say 3 minus -1 would also give us 4 for that distance. If two distances are equal, then the segments are congruent. So if the distance, for example, from A to B is equal to the distance from C to D, then we can say they're congruent. Here's where you're going to learn. I'm going to get a little nitpicky with this because I want us to learn this notation. So to say the distances are equal, we would simply say that AB equals CD. But when we're looking at congruency, we would say line AB is congruent to line CD. And you'll notice over to the right that this is 4 and this is 4, and that's why we know that they are congruent. The segment addition postulate then says, all right, if we have points A, B, and C, and they are collinear. Remember, collinear means they're on the same line. So we have these 3 points, and they're all on the same line. And we know that B is in between A and C. Then what we can say is that if we add up both parts, so if we add up AB plus the distance from B to C, that's going to equal the total distance from A to C. So we said, okay, B is in between there, so from A to B plus B to C equals the whole distance, AC. So let's look at a couple examples here for this. The first example, number 1, if PQ equals 9 and QR equals 28, then how far is it from P to R? Well, it would just be 9 plus 28, which would give us 37. And then for the next one, we're going to want to, let me erase that off of there. So if you're using pencil, go ahead and write it and erase it, whatever works for you. If QR equals 17 and PR equals 21, so if the whole thing equals 21, then we want to find how far is this piece. So we would do the opposite and subtract. We would find out that that piece is 4. Continuing on, we just get a little bit of algebra mixed in here. So if we look at number 4, TV tells us the whole thing is 14x minus 8. So our goal in the end is to find what is the distance from T to U. So we know that TU plus UV equals 14x minus 8. Then we're going to use that and do our algebra skills to solve for x, which will eventually help us find TU. So if I combine like terms, tx plus 7 equals 14x minus 8. And then I'm going to get my x's together and my non-x's together. So 9x, subtract from both sides, we'd have 7 equals 5x minus 8. Then I'm going to add 8 to both sides. And I would have 15 equals 5x. Divide by 5, and x equals 3. But that is not our answer because we want to find TU. So going back, we're going to plug in our x for TU. So 9 times 3 plus 2. 9 times 3 is 27, plus 2 would give us 29. And that would be our answer. All right, last example we're going to do together here. You're going to go back and you're going to work on the evens, but for now we're going to do you're going to do the odds. For now we're going to do the even ones. So for this one, C to E is 7x plus 4. So if we set that up, we know that part plus part equals the whole length. Then we're going to combine like terms. So we're looking to see, okay, let's combine our x's together. Let's combine our non-x's together. And then we're going to work to get them on the same sides. So x plus 8x would be 9x. 3 minus 9 would be negative 6. And then our right side here stays the same. Then I can subtract 7x from both sides. I'd have 2x minus 6 equals 4. Add 6 to both sides, and we'd have 2x equals 10. Divide by 2 to get x equals 5. As always in math, it's important to go back and look and see what does it ask us to solve for. Find the value of x. Oh, so in this case, we are done. You're going to do the odd ones, but we're going to go to the next page. On this page, then, we have the midpoint of a segment. So the midpoint of a segment is a point that divides the segment into two congruent segments. Midpoint right in the middle. A line, array, or a segment that intersects a segment at its midpoint is said to bisect. To bisect means to cut right in half the segment and is called the segment bisector. Again, when we think about it, it makes a lot of sense. But we're putting words and vocabulary and common language to what we are thinking about here. So in the diagram to the left, B is the midpoint of the line AC. Notice this line doesn't have an arrowheads on each side because it stops. It's a line segment AC. And line L is a segment bisector of line segment AC. Okay. You cannot bisect a line. You can only bisect a line segment because lines go on forever, and you cannot pick the middle of forever. All right, let's look at example 8 then. So if we know that they're the midpoint, and it means it's right in the middle, that tells us that this piece is going to be equal to that piece. So our setup for this problem is going to reflect that. 7x minus 16 equals 4x plus 2. So we're going to get our x's together by subtracting 4x from both sides. You'd have 3x minus 16 equals 2. Add 16. 3x equals 18. Divide by 3, and you would get x equals 6. That's what this question asked, so that's what we're answering. Sliding on down to number 11. G is the midpoint, and then it also tells us, this one's a little different because it tells us that FH is 6y minus 2. So what I want you to see here is our first setup is going to be 4x plus 3 equals 7x minus 12. Once we find that, we're going to have to plug back in your number for x in order to figure out y, because that's what we're asked to find. So you are going to work out the remaining examples that we did not do, and then if you're in person, you can check with Miss Massey. If you are remote, you can take a picture, submit, and then I will give you some feedback.